Now, once that is done, you just extract features from that block, as I said earlier, and it's up to you like what kind of features you want to use. It could be classical features, it could be your deep learning features, everything is fine. Now, here's the trick here, right? So it's fine, you can extract features, but how will you classify, right? So the way it works is, as you know that if you have to do detection, you need labels for annotations for that, right? So for the training samples, you should know like what exactly that bounding box will look like. So what you do is during training, again, you try to scan like those possible locations, and you will then have like some patches as positives and some patches as negative, because some patches will match the ground truth and some patches will not. So then what you can do is you can just collect those bounding boxes and create like a training set where you would have a positive class where person are present and negative class where person are not present. And you can just train a classifier. It could be a simple CNN classifier. It could be a SVM classifier, because in this case you have features. And once you have that trained classifier, then you can use that trained classifier during testing time. And during testing time, again, you take the same window, keep scanning on the images, and then that classifier will tell you whether person is present at that location or not. Okay, so this is just showing some sample examples which will be used for training. So all these are like positive cases because you have individuals present, and all these are negative examples. Again, you are extracting these samples from your annotations. Okay, so then you simply train like maybe a linear classifier, something like this. Yeah, it's up to you, like what kind of classifier you want to train. And we have seen like training a classifier, I think 2 different variations at least. Okay, so once that is done, we try to use that classifier to make predictions whether a person is present or not. And again, we do that at multiple scales. And of course, for preparing your training data, again, you will do that at multiple scales itself, right? So that will help. So you'll have to use some kind of threshold to say that, okay, object is present or not. Again, that's part of a classifier, you know all that. And this is, let's say, some sample result. You have this image. You again scanned all the possible locations, and then you try to classify all those possible locations. And then your algorithm might have said, okay, at this location person is present, at this location person is present, and that confidence level might be higher than the threshold. Okay, so remember, you need a threshold for a classifier. And if it's a binary classifier, you can say that, okay, 0.5 and above, it's a positive case, 0.5 and below, it's a negative case. So it's up to you. And again, that's like a parameter you have to decide. And let's say all these bounding boxes were detected as positive. Yeah, you can see like one issue you can clearly see, like at one location you have multiple bounding boxes, which in a way is right, because all these are correct, right? You have this individual present here, but then the question is, do we really need that many bounding boxes? In this sense, the algorithm is saying, okay, 1, 2, 3, 4 different individuals are present, but that's not true. We can only see one. And again, the other interesting aspect, you can see like you have some smaller bounding boxes as well, which means that you were able to take care of that scale aspect because you were trying patches at different resolutions. Okay, so that's fine. So that's like a initial step. You have these predictions, which is kind of already giving you results. But now we need to improve on this, and that's called post-processing. So we need to get rid of like these additional boxes. Okay, so let's see how we can do that. So as I said, you have multiple detections, and that's not good. So what we use non-maximum suppression, and we have seen this algorithm before. If you remember, like your edge detection algorithms, that's exactly what we were doing there. So the high-level concept of the algorithm is not going to change. Okay, it will remain the same. It's just a different kind of application.